This is Professor Antonio S. Marajas, and this is Advanced Digital Technique. Okay, so let's have an example on a three-variable map. No? So let's say we simplify the following equation using the K-map. So we have here problem number 1 and problem number 2. So how do we solve problem number 1? So what will be our solution? Again, this is a three-variable map. So we make a map representation. Okay, 8 cells again. So we have inputs A, B, and C. And this is 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. And we know that this is under A bar. This is under A. This is under B. This one here is B bar. B bar. And then we have here C. And we have C bar. Okay? So, for solution number 1, we locate this particular equation into our map. Since we are using SOP, so whatever is the location of these particular terms will have to be represented by 1. Okay? So first is your A bar, B bar, C bar. So we locate A bar, B bar, C bar into our map. So you have A bar, that means that it belongs in this particular 4 adjacent cells. And then you have B bar. So, ganun na lang ang choices, duha. And then C bar, that is this one. Okay? Diba? In our rule, it says single cell which cannot be combined represents a 3-variable term. So, that means a 3-variable term, single cell. Okay? Then you have 2-variable term. How many cells? We have 2 adjacent cells. Represents a 2-variable term. So we have AB, that is in this particular area. A is here, and then B is this one. Okay, so A, these 4 cells, and then B is these 2 cells. So the intersection of AB will be these 2 adjacent cells. And then you have A bar, C bar, 2 variable terms again, 2 adjacent cells. So you have A bar, this one here, and then C bar, that is one. These 2 adjacent cells. Okay? A bar, C bar. Now, since this one here has already a value of 1, so we just put a 1 on the other cell. And then you have A, B, C bar. Where is that? You have A, these 4 cells is A, then B, these 2 cells, then C bar, that is this one. So, since nanay 1, that means nga, dili na nato butangan og 1. Then you have B, C. Where's your BC? This is under B, and this is under your C. So, what is the intersection? B, C. So, this one, these 2 adjacent cells. Okay? Now, since there is already 1 here, so you just have to place a 1 there. So, that will be the location of your output. Okay? So, we group them according to our rule. The grouping will be what? 4, 2, 1. Actually, we can have 8, no? 8 adjacent cells because we have here 8 cells. But if, in any case, all cells here have a value of 1, then that means that x will be equal to 1. Okay? So, kung there is no 8 adjacent cells, we go to 4 adjacent cells. So, we have this one here as adjacent. Okay? And then we find another 4. Napo by 4 adjacent cells? I think there is none. Then we go to 2. Okay? Then we have here this cell which is not yet been grouped, and is adjacent to this particular cell, which is already grouped, we can still use this one to combine in this particular cell for us to have a two adjacent cells. So, pwede na ito isang gamiton para lang ma-maximize na ito ang grouping. So, that will be this particular group. Okay? So, since nag-group na tanan, then, no need to group this one because it's already been grouped into one group here. So, this will be represented by, again, this group here is under B, and this one here is under what? A bar, C bar. So, you have A bar, C bar. So, your equation will now be B plus A bar, C bar is equal to X. Again, why plus? Because this is product term, this is another product term, and they are logically added together. The sum of product expression. Okay, so what will be our logical circuit? So we have here AC. So you have an AND gate inverted. This one. So you have A, C, and then you have B. It's the AND gates AC complement and complement is being OR to B. So OR gate. Then this is your B. So that the output here is X. Okay? So that is for this particular problem, number 1. How about number 2? What will be our solution? Again, we make a map. So we know that this is under A bar. This is under A, B, B bar, B bar, C, and C bar. Okay? Then we locate this particular equation into our map. So you have two variable term, two adjacent cells. That is according to our rule, no? So AC. So you have this one here is A. This one here is A. Okay, and then C. The intersection of A and C is these two adjacent cells. Okay, then B bar. Where's B bar? This one here is B bar. These four cells are under B bar. So since nakani, so you all you have to do is to put another one here, and then B bar. Okay, and then ABC. Where's ABC? This is under A, this is under B, and this is under C. A, B, C. This one. So there is already a 1 there, so no need to place another 1. Then B bar, C bar. Where's B bar, C bar? B bar, and then C bar. This one. So there is already 1 there, so no need to place again the 1. Then you have A bar, A, B bar, C bar. You have A, B bar, C bar. There. So nanagya po yung 1 diha, so no need to place another 1. So again, we group them. So what will be our grouping? 8, 4, 2, 1. So again, maximize the number of cells to be grouped. Okay, so in this particular case, there's no 8 adjacent cells. So we go to 4 adjacent cells. So we have this one and this one are adjacent. So that will be our grouping. That's for the first group. And this cell here is not yet grouped, which is adjacent to this particular cell. So we use this cell here to group into this particular cell to maximize the grouping. So since all of the ones are already grouped, so you stop there and then you obtain the equation. So this one here belongs to B bar. And this one here belongs to AC. Okay? So, the equation now becomes B bar plus AC is equal to X. So, our logical equation will be, you have an AND gate represented by inputs A and C, and then we have B. So B is being OR to AC. So we have here an OR gate, B complement, that is your X. So that will be our solution for this particular example. Okay, so let's solve this particular map. No? We're still in the 3 variable map. Okay, so the first one is this particular condition. So how do we obtain the simplified logical circuit for this particular map? Again, so what will be our grouping? 8, 4, 2, 1. So since there is no 8 adjacent cells, that means that we go to 4 adjacent cells. So let's try to find 4 adjacent cells. Walay 4 adjacent cells. Now, here we have 3 adjacent cells, but then wala po 3 adjacent cells. Again, the grouping will be 8, 4, 2, 1. Okay? So since there's no 4, we go to 2 adjacent cells. What are these 2 adjacent cells? The first one is these 2 cells here. They are adjacent. So we group them as 1. Now, this one here, a cell which is adjacent to this cell here. So even if, again, this cell here is already grouped, we can use this to maximize the grouping of our cells. So this one here can be grouped into this particular cell. Okay? Then, is there other 2 adjacent cells? This one here and this one here are not adjacent. Okay? So, they cannot be grouped as 1. So, since wala na 2 adjacent cells, this one here belongs to a single group. So, what will be our equation? So, for this particular group, this belongs to A bar, C bar. Okay? 2 adjacent cells combines to yield a 2 variable term. And this one here belongs to B, C bar. B, C bar. No? Intersection of B and C bar. And then this one here belongs to A, B bar, and C. So that will be our equation. So generally, our final equation will be A bar, C bar, plus B, C bar, plus A, B bar, C is equal to X. Okay, so that will be our logical equation. And what will be our logical circuit? So we need how many AND gates? 1, 2, 3 AND gates. 1, 2, 3 AND gates. So you have A bar, C bar, A bar, C bar. So you have C, I mean. Then you have B, C bar, B, C bar. So you have B, C, and then A, B bar, C. So you have A, B, C, and then all of these AND gates are being ORed together. So you draw an OR gate. That is your X. That will be our logical circuit equivalent. Okay? How about for the other problem here? Okay, again, we find the grouping 8, 4, 2, 1. There's no 8 adjacent cells. We go to 4 adjacent cells. This one here is 4 adjacent cells in line. Okay, that is in line. And then we have here no more 4 adjacent cells, so we go now to 2 adjacent cells. Now this cell here, the remaining cell which has not been grouped, is adjacent to another cell, this one here. So we make use of this cell here to be grouped into this particular cell to maximize our grouping. Okay, so this one here belongs to what? C bar. Whereas this one here belongs to A bar B. So you have A bar B. So the final equation will be C bar plus A bar B is equal to X. Okay? So pwede ma-interchange. Pwede A bar B plus C bar is equal to X. It's the same equation. So what will be our logical circuit equivalent? So you have A bar B, and this is being OR to C complement. That will be your X. Okay? Then the last one will be what? This one. So the question here is there a 4 adjacent cell? Okay, I think there is none. So we go to 2 adjacent cell. Okay? So this one here and this one here are adjacent. So we group them as 1. Again, this one here is not adjacent to this one because it is blank here. So this one here is adjacent to this one since this one here is not yet grouped. So we make use of this cell and this cell to be grouped together. Okay? Is there any other 2 adjacent cells na paghapon, no? So this one, this is not yet grouped, but it is adjacent to this particular cell. Okay? So, nga nung adjacent sila because when you fold these 2 sides here, this one here and this one here becomes adjacent. So, we group them as 1. Okay? And then this one here is not adjacent to this one, so this is individually grouped 1. So what will be our equation? For this particular group, this group belongs to A and at the same time belongs to C bar. Okay? And this one here, this one and this one belongs to B bar, okay, and C bar, okay, and then this group here belongs to A and B bar. So that will be our equation. So the final will be A C bar plus B bar C bar plus A B bar. Oh, by the way, we still have this one. So this belongs to A bar and then belongs to B and belongs to C. Okay, so you have this one here plus A bar B C is equal to X. So what will be our logical equation? So you have 1, 2, 3, 4 AND gates. Then you have A, C bar, then B bar, C bar, and then you have A, B bar, then you have A bar, B, C. And these AND gates are being ORed together. So we draw an OR gate. This is our X. So this will be our simplified logical circuit.